Alright, so today we have another video lesson. I'm going to start this one off with a histogram question like number 3 from the homework. There's some issues with that in class, so I'm going to discuss how to how to set up the probability fraction basically. For a numerator, it's always the number of things in the event that we want divided by the number of things in the sample space, and this is where we had some trouble trying to find that sample space. So to find the sample space, we want the total frequency, which just means add the height of each column. So our first column has a height of 3, next one has a height of 8, and then 10, and then 9. So if we add those all together, then we get a total of 40. So now no matter what I ask, I'm going to be dividing by 40 because that's the total frequency of this problem. So now let's say I want to know the probability that the class scored between 70 and 90. So I'm looking at this interval here, which means I'd add the 8 and the 10 together. My probability would then be 18 over 40. So hopefully this helps with that problem. Alright, now we're going to begin 7.2, compound events. We're going to be discussing different scenarios where we have to account different events that create the overall probability. Let's go ahead and get started. Alright, so to begin with, we have a very simple problem. Create the sample space for rolling one die. We did this in class. We have all the numbers from 1 to 6. So 1, 2, 3, 4, 5, and 6. The next question then is, what's the probability of rolling a 5? How many 5s are there? Well, there's only one 5, so the number of things in the event is 1. How many things were in the whole sample space? There were 6, so our probability is then 1/6. My next question is, what's the probability of rolling a 2? Again, we're going to count how many 2s do we have. So in this case, we just have the 1. So we have 1, 2 divided by our 6 numbers. And then lastly, what is the probability that you can roll an even number? So for the even number, we have a 2, a 4, and a 6. There are now 3 things. So our probability is in 3 out of 6. So again, just to reiterate, the first number, our numerator, is always how many things there are in the event we're looking for. And then our denominators are always how many things are in the sample space. And we're counting how many there are. In class yesterday, I mentioned creating a 2D grid to create a sample space. Here's an example where that's going to be helpful. So we have a 2D grid for rolling 2 dice. We have the columns, which would be rolling the first die, versus our rows, which would be rolling the second die. And by combining all this together, we're going to get all the possible combinations. Alright, so here we have the completed chart. I strongly recommend that you copy this down because it's going to make any question involving 2 dice much easier. And the next couple examples are going to focus on this. So again, go ahead and copy this down. So hit pause now, and then move forward into the next questions based off of this sample space. Just to clarify a little bit though, if you look at any given pair, so let's say I have this pair here. This represents getting a 4 on one die, we're going to call that the first die, and a 5 on the second die. So order matters. Again, 4 on the first die versus a 5 on the second die. That's slightly different than this order pair, where we have a 5 on the first die and a 4 on the second die. So again, when creating our sample space, the order does matter. So here we have several questions that involve that last sample space. The first question is, what's the probability of rolling a sum of 10 versus a sum of 36? And then we have 2 other questions. What's the probability of getting a sum of 10 or 36? And finally, getting a sum of at least 12. In order to answer these, again, we want to look back at the sample space. So let's start with the first one, rolling a sum of 10. I want to look back at that previous sample space and find any combination of rolling the die where adding the numbers together add to be 10. So go ahead and hit pause now and count that. Alright, so there are 3 different ways that can happen. We get a 6 and 4, a 4 and a 6, or a 5 and a 5. So our numerator is 3. Our whole sample space has 36 outcomes, so our denominator is going to be 36. For the next question, what's the probability of rolling a sum of 36? In this case, that's impossible. The largest sum we can get is 12. So there are no ways for that to happen, which means this is the impossible event, or we have a 0% chance of that happening. For the next question, I want to get a sum of 10 or 36. Now remember, going back to our last unit, that the word or means to add our 2 things together. So in this case, I'm going to take my answer from part A and from part B and add them together. In this case, it's kind of unnecessary because we have 3 plus 0. But if it was a different number, it would affect our new probability. So our probability is the same, 3 out of 36. Looking at our last question, what's the probability of rolling a sum of at least 12? Well, the only way we can get a sum of 12 is by getting a 6 and a 6, which means there's one way for that to happen out of the 36 possible outcomes for our sample space. So we have a 1 out of 36 chance. Alright, for our next example, we're going to be drawing a card from a standard deck. So I want you guys to go ahead and hit pause now and try and create your sample space. So list all the cards, all the category of cards you can think of. Okay, so for our sample space, there's a lot of different ways we can look at this. To begin with, there's two colors. Half are black and half are red. So if I ask you the probability of a color, getting a red or a black, it's 50-50. Then we also have four suits. 2 black suits, spades and clubs, and 2 red suits, hearts and diamonds. So if I ask you the probability of getting hearts, there's one suit that's hearts out of the 4 suits, so you could say that's 1/4. If we break it down into exact cards, there are 13 cards. We have the numbers 2 through 10, and we have Jack, Queen, King, and Ace. Jack, Queen, King, and Ace are the face cards because they all have a face on them. And then the Ace we're going to use as our highest ranking card. It has no actual numerical value, it's just the highest card. So when I go down to my questions, the first one is a probability of drawing a king. Looking at our sample space, there's one king, but every suit has one. So the king of spades, a king of clubs, a king of hearts, and a king of diamonds, which means there are 4 total kings. So our probability then is going to be 4 out of 52 because there are 52 cards. The probability of drawing a black card, again that's a color, so since there are 2 colors, red and black, and one of them is black, we have a 1/2 probability, or 50%. And then finally, the probability of drawing a face card. So again, looking at our face cards, they are the Jack, Queen, and King. There's 3 different face cards, but each suit has those face cards. So there's 3 spades, 3 clubs, 3 hearts, and 3 diamonds for the Jack, Queen, and King, which means we have a total of 12 possible face cards out of the 52. Again, if you're not familiar with a deck of cards, I suggest that you get familiar. I do have decks in the classroom, so you can come by and look at them if you want to. But I'm going to be using these examples a lot throughout the rest of this course, or this unit. So you want to become familiar with it. Alright, here we have compound probability, which is combining 2 different outcomes. And it's normally listed as the probability of A and B. And the easy way to do this is to multiply the 2 different probabilities together. It's important to note though that in order to do this, we want to have independent events, which means that they have no effect on the chances of one other happening. So for example, if I say rolling a die and choosing a color, there's no way that rolling a die could affect choosing a color. But let's say that I want you to pick a card from a deck and you don't replace it, and then you're going to pick a second card. Taking that first card out changes the chances of getting all the other cards in the deck, so those would not be independent. So you have to make sure your things are independent in order to use compound probability. Let's go ahead and use some examples. Alright, so for this example, we have 2 people, Eric and Jenny. Eric has a 20% chance to make a free throw. Jenny has a 45% chance to make a free throw. The question is, what is the probability that if they both shoot a shot, they make it? So another way to say this is Eric shoots a free throw and makes it, and Jenny shoots a free throw and makes it. Since there's no way for Eric's shot to affect Jenny's shot, these are independent events, and since we're combining them, we now have a compound probability. So it's a probability of Eric making a shot and Jenny making a shot, which means that we want to take the probability of Eric making a shot and multiply by the probability of Jenny making a shot, which gives us 0.2 times 0.45. And the result is a 0.09, or 9% chance that both of them will make their free throw shot. Alright, so here we have the same scenario with Eric and Jenny taking a free throw, but now the question is that Eric makes it and Jenny doesn't. So Eric making it is a 20% chance, so we're going to take that, and Jenny doesn't. So if Jenny has a 45% chance of making it, she now has a 55% chance of not making it. And to find that, we subtracted the 45% from 100 because it's the complement, or the opposite. And now we can go ahead and calculate our answer. So we have a 0.11, or an 11% chance that Eric will make it and Jenny won't. Alright, same scenario. Eric and Jenny are shooting, and now the question is that they are going to both miss. So I want you to pause it now and try and find the probability that they will both miss. Alright, so for this problem we have the probability of Eric missing and Jenny missing. I use that complement notation to show that it's the opposite of them making it. Since they're independent events, we can just multiply them together, so we get the probability of Eric missing and the probability of Jenny missing, which is 0.8 times 0.55. Again, I got each one of these by taking the original percent and subtracting from 100, since it's the complement. When you multiply those two numbers together, we get 0.44, or 44%. Alright, here we have another classic example using marbles in a jar. So the first thing we want to establish is what is our sample space, or how many marbles are there in the jar. So we know there are 4 red, 2 green, and 6 orange. That gives us a total of 12 marbles. So that's going to be our denominator. We also know that we are replacing the marble, which is important because once we draw it, we put it back in. This means that every time we draw a marble, we have the same probability of getting every color. We want to get 2 red. So the probability of the first one is red is 4 out of 12. The probability of the second one is red is the exact same because that marble has been taken out and put back in. So we have another 4 out of 12, which gets us a total of 16 out of 144. For the purpose of this unit, I don't care if you guys reduce. If you wanted to multiply it out and get a decimal, you could. I'm going to leave them as fractions for now, and that is our probability. Alright, so now we want to get 1 red, then 1 orange. This then is really important because it tells us the order that we're going to be drawing in. So specifically, I'm looking for the probability that the first one is red and the second one is orange. If the word then wasn't there, if it instead was the word and that would mean that I could have a red and an orange, or I could also have an orange and a red. The order wouldn't matter. I just want to make sure I have those two. But again, I have the word then, so I don't have to worry about that. Okay, so the chance that we get 1 red is 4 out of 12. The chance the second one is orange is 6 out of 12. When we multiply that together, we get our combined probability of 24 out of 144. Alright, for our last example involving marbles, we want to get no red marbles. So what that means is I could get orange, or I could get green. I don't care what color it is, as long as it's not red. So those now are combined to be one set. We have 8 that are not red. The chance the first one is not red, 8 out of 12. The second one not being red is also 8 out of 12. So our probability is then 64 out of 144. Okay, this completes our notes. Go ahead and start the homework.